Okay, so welcome to all of you. Now we revise the chapter 2 of this calculus of several variables. The name of the chapter is partial derivatives and differentiability. So first we will see partial derivatives and after that we will see the differentiability. So what is the partial derivative? You are familiar with the derivative. That is the total derivative. How to differentiate with respect to it. Same thing we are doing here. So here what only slight change is there. So here what there are two variable, multi-variable function is there. Okay. Suppose we have these two variable function. Now we have to define fx and fy. So this is two variable, partial derivative with respect to x and partial derivative with respect to y. So this is also denoted by dou f by dou x or d by f by d by x. So this is fx. This is what dou f by dou y. This is same as fy. Okay, that means this is the partial derivative of f with respect to y. This is denoted by fy also. This is the partial derivative of f with respect to y. Okay, so this is partial. Now how to define this? Okay, so you have seen that dy by dx. So if y is equal to f of x y is equal to f, then dy by dx is limit h tends to 0, f of x plus h minus f of x upon h. Right? So this is what this is the derivative of f with respect to. This is called a first principle. Okay. Now same thing here. So dou f by dou x. This is same as fx of xy, or you say this is what ab now. Okay. So we will define fx ab now. Fx ab. So fx ab means what? Dou f by dou x at ab. So this is what? Limit h tends to 0, f of a plus h b minus f of ab upon h. Okay. Similarly, fy ab at point ab, dou f by dou y at ab, limit k tends to 0, limit k tends to 0. So we are differentiating partial with respect to y. So here we are differentiating partial with respect. So what we did here? We have so what your x coordinate is increased by h only here and the form as it is now. Okay, so same thing here, what we are differentiating partial with respect to y, that means we will increase the y coordinate by k now. Okay, so this is a b plus k minus f of ab upon k. Very simple formula. So if you want to general definition, just fx, this is what? Limit h tends to 0, f of x plus h y minus f of xy upon h, and this fy, this is the general definition. Limit k tends to 0, f of x y plus k minus f of xy upon k. Okay, so this is the definition of the partial derivatives. So same thing here. Suppose we have the three variable function. Suppose you have f of x y z. You have f of x y z. Then dou f by dou x is same as what? Limit h tends to 0, f of x plus h y z minus f of x y z upon h. Okay. For y, we have for dou f by dou y, same thing here. For dou f by dou, we are writing here k tends to 0. We will increase only the y k plus k here only. X will be as it is now. F of x y plus k z and f of x y z, okay, upon k something. So for z we will write here r now. Okay, r tends to 0, f of x y z plus r minus f of x y z upon r. Okay, so this is for 3 dimension or any dimension you can write. Suppose we have a function, we have this function. Okay, suppose f of xy is equal to xy square minus x cube y. Now we want to differentiate this. We want fx. They will ask the like this f of x11 or something else. Only important part what we have to differentiate correctly. Okay, so fx means what? We want to differentiate f with respect to x. That means what? We have to keep y as a constant now. Other variable as a constant, whatever it may be. Okay, so only I have to differentiate with respect to x. So partial with respect to x. That means other than x, all the rest of the variables are created as a constant. So this is what here x y square. Y square is constant. So derivative of x is 1 now. So this derivative of xy square will be simply y square. minus derivative of this 3x square. Y is a constant, it will be as it is. So fx 1 1, then fx 1 1 is same as what? 1 minus 3, that is 2, or minus 2, that is minus 2. We will find fy also. Fy, your x is constant now, derivative of y square is twice y, so twice xy. Here what your y, x cube is constant, only we have to differentiate y. So derivative of y is 1, so this is minus x cube. So fy 1 1 is same as what? So again 1 minus 1, this is 2 minus 1, so this is 1. So you have to put x is equal to 1, y is equal to 1. So this is what? 2 minus 1, so this is 0. 2 minus 1 is 1 now. Okay, so suppose you have f of xy log of x upon y, log of f, and you want fx and fy. So you can write this as log x minus log y. If there is a log, always simplify this so that you can differentiate easily. So no need to apply uy rule and so on. So what is then fx? Fx is at 1 by x. Well, log y is constant. So derivative of log constant is 0. Then fy. So minus is there. Log of x is 0. Derivative of log x is 0. So this is minus 1 by y. Okay. So in this way you can differentiate the function. You can find the value of fx and so on. You can do this with the help of the definition or without definition. Now suppose we have such type of function. We have such type of function. F of xy is equal to xy upon x square plus y square. Xy not equal to 0 0 and is equal to 0. Xy is equal to 0 0. And you want fx 0 0 and fy 0 0. Fy 0 0. Okay, we will see how to find this one. Okay, so this is given to. We will write the formula for fx 0 0. So what is that? Limit h tends to 0. F of 0 plus h 0 minus f of 0 0. Very simple. Okay. So what is this then? Limit h tends to 0. This is what f of h 0. This is what f of h 0. That means this is your f of xy. Xy not equal to 0. You have to put x is equal to h and y is equal to 0. If you put x is equal to h and y is equal to 0, this is 0. And f of 0 0 is already given to you. This is 0. So 0 minus 0 upon h. So numerator is 0. This is 0. Okay. Very easy now. This is what fy 0 0. This is what limit k tends to 0. You may say here h tends to 0. Doesn't matter this. So this is what f of 0 0 plus k now here minus f of 0 0 upon h. So this is what upon k. So this is what limit k tends to 0. Now f of 0k. This is f of 0k. That means here put x is equal to 0 and y is equal to k. So 0 into k. This is 0. So 0 upon anything is 0 now. Minus 0 upon k, again this is 0. Okay, very simple, right? Such type of example you have to do for the internal exam or internal exam one. So whatever this online exam. Now if you consider this f of xy is equal to mod x plus mod y, this function is continuous, but fx 0 0 fx 0 0 and fy 0 0 do not exist, does not exist. Note that this does not exist, is not exist. Similarly, f of xy is equal to mod of xy. This also same as the case. Suppose we have this function f of xy is equal to x cube minus y cube upon x square plus y square. Xy not equal to 0 0 is equal to 0. Xy is equal to 0 0. So what happened? Fx 0 0. We will find only fx 0 0 now. Just write the formula. Limit h tends to 0. F of 0 plus h is h minus f of 0 0 upon h. So f of h is 0. You have to put x is equal to h and y is equal to 0. So what happened? This is h cube upon h square minus 0. F of 0 0 0 upon h now, right? This is what limit h tends to 0. So this is h cube upon h cube. So this limit is 1 now. Okay. Now fy 0 0. So this is what limit k tends to 0. F of 0 k minus f of 0 0 upon k. upon k. Okay, so you have to put x is equal to 0 and y is equal to k. So this is minus k cube upon k square. So minus k cube upon k square means this is what? K minus 0 upon k. So this is what? Limit k tends to 0. So minus k upon k is minus 1. So this value is minus 1. So your first partial derivative is minus 1 and first partial derivative with respect to x is plus 1. First partial derivative with respect to y is minus 1. Okay. So I hope that you understand this one. You can solve any problem on this. Okay. So I hope that you don't have any problem for this one. Just we are revising this one. We are not taking all examples. Suppose we have this function f of xy is equal to x cube plus x square y cube minus twice y square. Okay. And you have to find the value of this one fy 2 1. Okay. This may ask like this. So what is fx? Just we will find fx and just we will find fy. You can find fx 2 1 and fy 2 1. So what is fx? We are differentiating with respect to x, partial with respect. That means your y is constant here. So y is constant. So this is 3x square plus twice x y cube as it is. Derivative of twice y square will be the 0. So you can find an fx 2 1. Fx 2 1. Put x is equal to 2 and y is equal to 1. Okay. So you can find the value of this one. Fy. We have to differentiate partial with respect to y now. That means your x is constant. So derivative of x to be 0 now. So this is what x square will be as it is. Derivative of y cube is 3y square. So this is 3y square minus 4y. Okay. So this is your derivative. You can find the value of this fy 2 1 and so on. Okay. You can differentiate twice also. No problem for this one. Okay, so I hope that you understand this was the basic concept of this one. So now second order partial derivative. Okay, so fxx is that means what? You are differentiating fx partial derivative x. That means what? The formula is what? Limit x tends to 0. We are differentiating fx now. So this is what? Fx ab, suppose this is a plus h b minus fx ab upon h. Okay. Suppose you have to differentiate fxy ab. Okay. So this is what you are differentiating fx partial with respect to y. So this is what? Limit k tends to 0 fx, okay, a b plus k minus f of ab upon k. Okay, so then fx fyx suppose. So this you are differentiating fy partial with respect. So this is what? Limit h tends to 0. So fx fy, this is fy. We are partial differentiating with respect to x. So this is what? A plus h b minus fy ab upon h. Okay. So now then fyy. This is second order partial derivative. So this is fyy. That means you are differentiating fy partial with respect to y. So this is limit k tends to 0. You have to increase your y coordinate of fy by k now. So this is what? B plus k minus fy ab upon k. Okay. So these are the second order formula. You should remember this. So if 0 0, then replace a as 0, b as 0, you get the formula. Okay. So with the help of the definition. Okay. These are the second order. Okay. So suppose you have, okay, so you have this function. Okay. Now we want fxx. You want fxx. So first we have to find fx. So that we already did. Again we have to differentiate with respect to x. So that is what? 6x plus 2y cube. Okay. fxy now. fxy. You have to differentiate fx partial with respect to y. This is your fx. You have to differentiate partial with respect to y. So this twice x is constant. Derivative of y cube is 3y square. So this is 6y square. 6y square. Okay. Now fyx now. You have to differentiate fy partial with respect to x. This is your fy. You have to differentiate with respect to x. So this is what? 6x. Y square is constant. Okay. So derivative of 4y 0 because y is constant. 4y is constant. Okay. So now fyy. We have to differentiate with respect to y. So derivative of y square is twice y. So this is what 6x square y minus 4. Okay. So these are the derivative or partial derivative. In this way you can differentiate anything. Okay. So these are the second order. Okay. Try to solve number of problems. So you can try to solve the number of problems. Even though you can differentiate fxx also. Fxx means what? Fxx. You have to 3 times differentiate with respect to x. This is your fx. So this is what? 6 times. This is 6. So orally also you can do this one. So this is what? Third order partial derivative with respect to x. So you know that the second order and all the 0. So these are the 0 now here. Direct orally. This x cube is nothing but 3 factorial. So this one 3 factorial. So see, we get the 6 here. Okay. Orally also we can write this third order. Because what? This is the third derivative with respect to x actually. So the second power of x is 2. Then that derivative is 0. Only x cube and higher power will be the remains for this derivative. Okay. So this is derivative 0. This is constant. This is 0. So derivative of x cube and x to the power 4 also can do this one. Okay. So only I have to differentiate this x cube for the third order derivative. Okay. Rest are the 0 then. Okay. Orally also you can do this one. Now suppose you have the function u is equal to x log of xy. X log of xy. So now you have to find u x suppose. So I can simplify this. This is log of. So log of x plus log of y. Okay. U is equal to x log x plus x log y. Okay. Now if you want uxx, 101% is derivative is 0 because there is only x. So here x log x. Only differentiate this 3 times. X will be as it is 1 by x plus log x. This is one time differentiate. Then you have to differentiate. This is what 1 plus log x. This is one times. Okay. Second time differentiate is what 1 by x. Third time differentiation 1 by x square. So end of this is what 1 by x square. Uxx is 1. Okay. So if you want u yxx, then you have to write uy now. First uy. So uy is what? X upon y. X upon y. Right? Because what? We are differentiating with respect to y. This is x log x is the constant. So this is 0. Then what? Uy x is what? 1 by y. And uyxx is 0. See, this is 0 then. Because second order derivative. First you are differentiating, second order derivative, your x is there. Second order derivative is 0. So uyxx is 0. Easily you can find this one. Okay, if your concept is clear. Now what? You should face any problem for the partial derivative. Take any function, you can easily differentiate that. So that is your part now. So differentiability. For differentiability. That means what? When we say that a function is differentiable, if this increment epsilon 1 tends to 0, epsilon 2 tends to 0 as delta x, delta y tends to 0, 0. Okay. If your increment is expressed like this, right, where epsilon 1 and a and b are constant, okay, epsilon 1 and epsilon 2 are tends to 0, whenever your delta x and delta y tends to 0. So this is what? This is also called as delta f. Delta f is equal to a delta x plus b delta y plus epsilon 1. Epsilon 1 is a function of delta x and delta y. Epsilon 2 is also a function of delta x and delta y. Then we say that the function is differentiable. Okay. So that is what? This also we can write that is equal to a delta x plus b delta y plus epsilon delta x plus epsilon delta y. You can write here phi and psi also. Some phi of function of delta x and delta y, psi of function of delta x and delta y. Phi and psi, any notation you can apply here. Okay. Then important in the differentiability is the necessary condition for differentiability. Necessary condition means what? What happens if f is a differentiable? So necessary condition is what? F is differentiable at AB, then if your function is differentiable at AB, then f is continuous at AB. Function is continuous at AB, and both the first order partial derivative fx and fy exist at AB. म्हणजे जर फंक्शन डिफरन्शिएबल असेल तर ते फंक्शन कंटिन्यूअस असतं आणि दोन्ही फर्स्ट ऑर्डर डेरिव्हेटिव्ह एक्झिस्ट होतात. पण जर फंक्शन कंटिन्यूअस असेल, दोन्ही फर्स्ट ऑर्डर डेरिव्हेटिव्ह एक्झिस्ट होत असेल तर फंक्शन कंटिन्यूअस असेलच याची गॅरंटी नाही. सो रिव्हर्स इज नॉट एक्झिस्ट. That means what? Function is continuous. First order partial derivative exists. Right? This does not imply that your function is differentiable. But your function is differentiable, then these two are code here. Okay? So this is the main point here. So you should remember this. So converse is not true. Converse is not true. This is the example. F of xy mod x plus y square and f of xy is equal to mod of xy. These two examples are very important here. So here what mod x is there? That means what here? Fx00 does not exist. So see, but what? F is not continuous, function will not be differentiable. First order partial derivative does not exist, one of them partial derivative does not exist, function is not differentiable. So here what? Fx00 does not exist, so this is not a differentiable function. And for mod of xy also, so here what? Function continues, first order partial derivatives also exist. Here fx00 exists. Fy00 also exists. Okay, function is continuous. See here, function is continuous. Function is first order partial derivative exists, but that function is not differentiable at origin. So mod of xy is not differentiable at origin. Both the first order partial derivatives exist at the origin. The function is also continuous at origin. So converse is not true. This is the example. So this is what f of xy is equal to mod of xy is the example of the converse is not true. Example of this one, right? So this the converse is not true. This is the counter example of this theorem. Okay, so converse is not true. We are saying that converse is not true, and the counter example is what? F of xy. This is the mod of xy. Our function is continuous. First order partial derivative exist at 0, but the function is not differentiable at 0. So this is the nice example of the converse of this theorem is not true. Okay. So here what some approximation is there. So you should remember that approximation. We are familiar with that approximation. So find the approximate value of this one. You will see that problems on the approximation. Okay. So that we have to do the manually. I am not doing here. Okay. The next chain rule is there. Chain rule. Okay. So for chain rule, suppose u is equal to f of xy. U is the function of x and y, and x is the function of phi of t, y is some psi of t. That means x is the function of t, y is the function of t. That means automatically u is the function of t, single variable t. So du by dt. Right? What is the formula for this one? So du by dt is same as dou u by dou x, because u is the function of x. You cannot directly differentiate u with respect to t now. So dou u by dou x. So dx by dt. Why dx by dt? Because x is a single variable function, y is also single variable function. Therefore, we are writing dx by dt. Okay. Plus dou u by dou y, dy by dt. Remember this. This is the chain rule for the single variable function. If u is equal to f of xy and x is a function of uv, x is a function of x is the function of uv, y is equal to y is the function of uv, then this is w, we'll say z, okay, we'll say z is the function of f of xy, x is the function of uv and y is the function of uv, and that means what, z is the function of uv, that means you have to find dou z by dou u. What is dou z by dou u? You cannot differentiate z directly with respect to u because your z is a function of x and y. So this is what, dou z by dou x into dou x by dou u plus dou z by dou y by dou u. Okay, so remember this, there are these two chain rules, dou z by dou v, dou z by dou x by dou v plus dou z by dou y by dou v. Remember these two chain rules. This, for this you should remember the formula. If you don't remember the formula, you cannot solve the problem on the chain rule. Okay, so the problems are very easy. Okay, so you should remember this. We don't need the proof of this one because we are facing the online exam. Okay, so no need to face multiple choice question, so no need to prove this one now. Okay, after that, the homogeneous function is very important. Homogeneous function. Homogeneous function. Okay, so a function f of xy is said to be, definition is very important, is said to be a homogeneous function of degree is very important here, of degree n, if f of tx ty is equal to t to the power n f of xy. So what, if you replace x as tx, y as ty, then whole t is common, power of t common, and we get the original function as it is now here. And whatever the power of this n is nothing but the degree of the homogeneous function. Note that n is a real number, n may be a real number. So minus half, 3/2, something like this. So it should it may be natural, may not be natural, it should be the real number. Okay, so whatever the n, you have to accept this. You have to, whatever the power of t, yeah, that will be the degree. It may be minus 3/2, 3/2, root 2, whatever this. Okay, so that is the degree. Degree is very important. One thing is also defined like this, f of xy is equal to x to the power n phi of y by x. X to the power n pi by x. This is also definition. So this is also definition, y to the power n some psi of, so x by y. This is also homogeneous function of degree n also. Okay, so it is better to remember these two only. Okay, so remember this, what is meant by homogeneous function. Okay, so now first we will see Euler's theorem, and then we'll see the simultaneously we'll see the homogeneous function and Euler's theorem. So what is the Euler's theorem? This is very important. Euler's theorem. F is a homogeneous function of degree n, then x dou f by dou x, this is very important, x dou f by dou x plus y dou f by dou y is equal to n times f. This is very important. So that means what, if you know the function is homogeneous, if they ask x dou f by dou x plus, no need to differentiate partial with respect to x, no need to differentiate partial with respect to y, no need to multiply x, multiply y and take the addition of this one, no need to do. If you know the function is homogeneous, directly the answer is what, n times f. So sum of this one will be n times f. Also this x square dou 2f by dou x square plus twice xy dou 2f by dou x dou y dou x, whatever this, the order is important here, plus y square dou 2f by dou y square is equal to n into n minus 1 times f. Directly you can find the value of this one also. Directly you can find the value of this one without finding the first order partial derivative or the second order partial derivative. This is the Euler's theorem. If you know the function is homogeneous, directly you can find the value of this one. Okay, without differentiating the function. Okay, so this is important thing is that this is very important. This is very important. This is what n into n minus 1 times f and this. Okay, so we'll see some problems on it. Problems on it. Okay. Okay, we'll take some examples. Suppose z is equal to x square plus y square plus xy. X is equal to sin t, y is equal to cos t, e raised to t, and they want dz by dt. They want dz by dt. Or if you say f, then this is what df by dt. If they say capital F, then this is capital F by dt. So what is this? Dz by dt. Okay, so dz, this is not dz. Very simple. This is dz by dt. Okay, so what is this? Dou z by dou x into dx by dt. This is very important formula. Divided by 1 dy by dt. Okay. So what is dz by dx? This is twice x plus y. Twice x plus y. Dx by dt is what? Cos t. Dx by dt is cos t. Dz by dou z by dou y is twice y plus x now. Plus derivative of y, derivative of x square is 0. Derivative of y square twice y. Derivative of xy is just x. And this is what? E raised to t. If they want dz by dt at t is equal to 1, what you have to do? So what here? X at t is equal to 1 is what? Sin 1. Y is nothing but what? Y at t is equal to 1 is what? Just e. Okay. So what is that? The 2. X is what? 2 sin 1 plus e cos 1. Cos 1 plus twice y. Y is what? E. X is what? Sin 1. Sin 1. E. This is e. Okay. At t is equal to 1 this value. Okay. In this way you can find dz by dt, whatever this may be. So we have given some examples here in books. So do all the problems on it. Suppose you have this function z is equal to tan inverse of y by x. Find x dou z by dou x plus y dou z by dou y. Okay, if you want to find like this. Okay, so what is this? This is x dou by this is just like as Euler's theorem. Okay, if you know this is a homogeneous function, then directly you can write. What is the homogeneous function? Just replace x as tx and y. See here, if you replace x as tx and y as ty, your tt get cancelled. So that means what here? Z of tx ty is what? Is same as z. Is same as this is what? Tx ty. So this is what? Tan inverse of y by x. That means this is what? T raised to 0. Tan inverse of y by x. That means this is a homogeneous function of degree 0. So then this is what? Then this is what? 0 times f. That means what? It is 0. No need to find this. No need to find this. Okay. So but usually if they want the value of this one, so what is this then? Dou z by dou x. Just to find. Tan inverse of what? 1 upon something square. Y square upon x square. Into derivative of something. So y will be as it is. Derivative of 1 upon x is minus x square. Right? So your x square will what? Here get cancelled. So this is minus y upon x square plus y square. This is your dou z by dou x. So dou z by dou y will be what then? So 1 upon 1 plus something square. This is the derivative of tan inverse of something. 1 upon 1 plus something square. Into derivative of this y by x. So this is what? 1 by x. Then you are multiplying by x here. Your x will be x square will be here. X will get cancelled. So x upon x square plus y square. Okay. This is your dou z by dou y. Okay. So if you have to multiply by x and you have to multiply by y, and see your denominator are 0, your numerator are equal but opposite, it becomes 0. But no need to find this. If they want x dou f by dou x and y plus y dou f by dou y, don't do this manually. Okay. Use the Euler's theorem. But for that you should know whether this is homogeneous function or not. If it is homogeneous function, you should know the degree of the homogeneous function. So without degree of the homogeneous function, you cannot solve. Okay. So there are many problems. We have solved this in book. So just check and find the small values of this. Okay. Okay. Suppose u is equal to x raised to half plus y raised to half x raised to n plus y raised to n. And find x dou u by dou x plus y dou u by dou y. If like this, and function is very complicated now, and you have to face this problem for the internal exam for MCQ, right? Online exam. So what is this? This is just like a Euler theorem. Just check whether it is homogeneous or not. So if you put tx, ty here, tx here, so this is what n plus half now. From this is what? From this is what? Half. This is t raised to n, and this is what? T raised to n will be out. T raised, because what? N is here, n is here. You can take t raised to n common. Here what? T raised to half. So t raised to half plus n. So this is what? 1 plus twice n upon 2 is the degree of the homogeneous equation. So what is that then? This is what? 1 plus twice n upon 2 times u is your value. This is your value. This is the homogeneous function of degree 1 plus twice n upon 2 or half plus n into twice n. Both the thing you can, whatever the option is there, just you check this. Okay. Suppose u is equal to sin inverse of x upon y plus tan inverse of y upon x upon or y upon x. So what is x? X dou u by dou x plus y dou u by dou y. What is x square? Dou 2u by dou x square plus twice xy dou 2u by dou x dou y plus y square dou 2u by dou y square. If they want these values, then what? So here it is very complicated, right, to do manually, but we have the Euler's theorem, right? If the function is homogeneous, then no problem. So whether the homogeneous, if you put x is equal to tx and y is equal to ty, your t get cancelled here, your t. No t remains here. No t remains here. So that means what? This is a homogeneous function of degree 0. So this is what? 0 times f. This is what? 0. This is what? 0. 0 minus 1 times f. So 0 minus 1 times f is also 0 now. So this is 0. Very easily you can find this one. If you know the meaning of the homogeneous function, if you have the idea to check whether this is homogeneous function or not, then easily you can face such type of the problems. Now suppose we have this function u is equal to tan inverse of x cube plus y cube upon x minus y, and the problem is that find x dou u by dou x plus y dou u by dou y. Again the same problem here. Again the same problem. See here, if you put x is equal to tx and y is equal to ty, so here what? Your t cube will be from the denominator and t from the denominator. So this is what? X cube plus y cube upon x minus y will be there. So this is what then? But this is what? Tan inverse of t square x cube plus y cube upon x minus y will be there. But t square you cannot take out. That means u is not a homogeneous. That means u is not homogeneous. But if you shift this tan inverse to this side, then tan of u, this will be what? Tan of u. So if you do like this, what you get? Then tan of u is like this. Tan of u will be your homogeneous function. Tan of u will be your homogeneous. Then what? Then this is what? N. N times your u upon u dash then. U upon u dash. F of u, f dash u. F of what? F dash of u. So if your f of u is the homogeneous function and they want h dou u by dou x, your tan u is the homogeneous function. That means f of u is the homogeneous function, right? But what here? Your h dou u by dou x this. Then this is what? N is the degree of the homogeneous function, and this is f of u upon this. So what happened then? This is tan u is the homogeneous function of degree 2. Then this will be 2. Then tan u will be as it is upon the derivative of tan u. This is what? Sec square u. So this is what? Tan u means what? Sin u upon cos u, and sec square u means what? Cos square u. So this is what? 2 sin u cos u. So this is sin twice u. See what is the option? So that option you have to correct. You have to choose the correct option. So there may be sin of twice u. There may be like this. There may be 2 sin u cos u. So this will be the correct option. Okay. Okay. Now suppose we have this function u is equal to log of x raised to 4 y raised to 4 upon x plus 1. Find x dou u by dou x plus y dou u by dou y. Okay, so log is there, that means just shift log here. So this will be e raised to u, x raised to 4 plus y raised to 4 upon x plus y. Okay, orally you can find the degree of the, this is what t raised to 4, from numerator t raised to 4 is common, from denominator t is common, t raised to 4 upon t, that is t cube. So degree of the homogeneous function is t cube, is 3, right? But this is what e raised to is homogeneous function, so e raised to u upon derivative of e raised to u is e raised to u. So that means what, the value of this one will be 3 only, value of this one will be 3 only. Now that this formula is not applicable for that, because what here e raised to u is homogeneous, so don't write that is n into n minus 1 times f for the second order difference. Okay, so that will not work here. Okay, so if e raised to u is homogeneous, then that work, the second order formula, the corollary of the Euler's theorem. Okay, so that hold. Okay, now next, suppose u is equal to sin inverse of x plus y upon root x plus root y. Okay, if you shift the sin inverse this side, so this is what sin u, this is what then x plus y upon root x plus root y, root x plus root y. If you put x is equal to t, tx and y is equal to ty, from numerator t will be here and from denominator root 2 will be here. So this is what then t raised to 1 minus half, root t means what, t raised to half, it will be at the numerator there. This is what, then this will what, 1 half. So this is a homogeneous function of degree half. Then what is your value? This will x dou by dou x plus y, value will be what, the degree is half. Your function is sin u upon derivative of sin u is cos u. So this is 1 half tan u is your required answer. Tan u is the required answer. Okay. We did lot of problem for you. Okay. Suppose u is equal to x square tan inverse of y by x minus y square tan inverse of x by y. Evaluate x square dou 2 u by dou x square plus twice xy dou 2 u by dou x dou y plus y square dou 2 u by dou y square. Okay, we'll also take the problem, evaluate dou u by dou x plus y dou u by dou y. Okay, without this you cannot do this one actually, but this is the problem for MCQ, so then directly you can solve this one. Okay, now here what, if you put x is equal to tx and y is equal to ty, this is what, t square x square here, t square x square here, and t get cancelled here. So that means what, whole t square is common, from t square common from here, so t square into we get this one, so that means this is a homogeneous function of degree 2, so this is what then, this is twice u, and what is this then, 2 into 2 minus 1 times u, so again this is twice u. Both the answers are same now here, both the answers are same for this one. Okay, now suppose u is equal to f of x y, x upon y, so then x dou u by dou x plus y dou u by dou y. What is the value of this one? So this is what, if you put x is equal to tx, t get cancelled, that means there is no t remains, that means it is 0. This is a homogeneous function of degree 0, so this will be what then, 0 times u, so this will be 0 now. Okay, so suppose x times this, then this will be what, x times f of x y, so tx, t get cancelled here now, only t remains here, right, t to the power, that means this is a homogeneous function of degree 1, so 1 times f now, 1 times u or 1 times f, that means what, u or f, whatever the answer, u or f. Okay, anything is okay. Next, v is equal to, suppose we have this x cube y cube upon x cube plus y cube. What happened here? So t cube t raised to 6, 3 plus 3 6, and upon t cube will, here what, t cube common, so that means this is a homogeneous function of degree 3 now, this is a homogeneous function of degree 3. So what is the value of this one? Then first one, this will call first one, this will call second one. We will not write again and again for this one. Okay, for first one x square by dou v. So this will be dou v then. Okay. So that means this is what 3 times v, and this is what 3 minus 1 times v. So that means what 6v. This will be what 6v. So here what everywhere you have capital V. Okay. So here what the degree is very important now. Degree is important. Okay. So we'll take an example. U is equal to root of x square plus y square sin inverse of x upon y, sin inverse of x upon y plus, okay, only this. Okay, what is this here? T square common you can take. Okay, but t square will be out then. Here what tx upon t get cancelled, no problem for this one. Okay, so if there are such type of function, t should be get cancelled inside the angle. T should be get cancelled. If t is not cancelled, then that will be not homogeneous. Okay, so now here what t, this is what homogeneous function of degree 1. So this will be what u, and this will be 0, because what n into n minus 1, right? So that will be 0. So second order, that will be 0. Suppose u is